Hi everybody. In this video, we're going to talk about range and mean absolute deviation, or MAD for short. That's the acronym for mean absolute deviation. And both of these things are measures of spread. They give us an idea of how spread out the data is. Is it just a little bit spread out, or is it very spread out? Okay, so the first one, which we will calculate, is range, which is incredibly simple. To find the range, just subtract the minimum number from the maximum number. So over here we have two data sets. Let's say that these are test scores for two different classes, class A and class B. To find the range, we're just going to take the minimum number and subtract it from the maximum number. The minimum number just means the smallest number in that data set. The maximum number means the biggest number in the data set. Subtracting the minimum from the maximum means we start with the maximum and then take away the minimum. So let's do that. What is the smallest number in this data set here? And you can see I did plot them on the histogram, so it's easy to see on the histogram. But you could also just see, if I were to give you some numbers without a histogram, just look for the smallest one. So the smallest number here is 10, and of course 10 is the lowest number that is plotted on the histogram. And the largest number is 90, and of course 90 is again the largest number which is plotted on the histogram. So to find the range, we're just going to do 90 minus 10. Which is 80. Okay, so in other words, it's a distance of 80 points from the lowest number to the highest number. It's 80 from here to here. So the highest kid in the class, the kid who scored the highest got a 90, not the highest kid, but the kid who scored the highest got a 90. The kid who scored the lowest, unfortunately, he got a 10. The difference between those numbers is an 80. So the grades for this class, you can see, are pretty spread out, okay? And we actually did not even consider these other numbers over here. We were just considering the largest one and the smallest one. In class B, the smallest number is an 80. The largest number is 100. So to find the range there, we would do 100 minus 80, which is 20, okay? So it's from here to here is 20 points, right? This is 80 points, and then the kid who got the highest got 100. So the difference between the kid who got the highest and the kid who got the lowest is 20 points. Not as much of a difference as it was back here. So this is some indication that the scores for class B are less spread out than the scores for class A. Again, notice that we didn't use any of the middle numbers. We only used the numbers on the ends. So the fact that we are ignoring so many of the numbers when we calculate the range, and we're only focused on the biggest and the smallest, it is kind of a flaw in having this measure of spread, because it does lead to some counterintuitive conclusions. So for example, if you take a look at this data set over here, the biggest number, the highest that anyone scored on that test, is 100 again, and the smallest number is a 90. Okay, and so the range would be a 10, which is relatively small, which is telling us that this data is not very spread out. It's pretty close together. So far, so good, actually. No problems there. We got a small number for the range, and the data is very close together. It's not very spread out. So that makes sense so far. But what if we included just one other piece of data, which was right over here? Then what would the range be? Well, the maximum number is still 100. Now the minimum number is way over here, and that's 30. So the range would be 70. So now we're saying that the data the range went from 10 to 70. So we're saying that the data is a lot more spread out now. And yeah, I guess that's kind of true, right? Because we do have this point over here, but still most of the data is very, very close together. So the fact that we are ignoring so many of these data points over here when we do the range, we're completely ignoring them and we're only focused on the biggest number and the smallest number. It can lead to some counterintuitive conclusions when you have, for example, like this, a data set where most of the data is close together, and yet when we calculate the range, we get a very big number just because of that one point which is far away. Okay, so that's a problem with the range, and that's why people also choose to use another measure of spread, which is called the mean absolute deviation. So let's talk about that now. For the mean absolute deviation, we're not going to just use two of the points and say that that's giving us enough information to calculate how spread out the data is. We're going to use all of the points of data when we calculate the mean absolute deviation. So it's a three-step process. Step one is to find the mean. Okay, so I already did that over here. So you can see here for class A, to find the mean, just like we talked about in another video. If you didn't watch that video yet, I'll just briefly describe it. It's pretty easy. To find the mean, you just add up all the numbers and then divide by how many numbers there are. So first, step one, let's find the mean. We'll do 60 plus 10 plus 90 plus 80 plus 30, which is 270, and then we'll divide by how many numbers there are. So that's 5 numbers, so we divide by 5. So the mean for this data set is 54, and I am going to draw an arrow right over here at, so 54 would be about halfway between 50 and 60, maybe a little bit closer to 50, right? So the mean would be right over here. Step two, we want to find the distance between each number and the mean. So in other words, if the mean is 54, then how far is this point from 54? This point is at 60. How far away is 60 from 54? In order to answer that question, we would just subtract. We would do 60 minus 54. And you can see I did that for all of these data points. So in other words, for 30 over here, how far away is 30 from 54? Well, the way to answer that would, again, be to subtract. The problem is if we do 30 minus 54, we would get a negative answer instead of a positive answer. We want a positive answer for this, okay? And that's why we're actually going to be taking the absolute value after we subtract. Let me just show you this, and then it'll make a lot more sense. Okay, and that's where the word absolute comes from, because in this step here, in step two, we are taking the absolute value of those numbers. I kind of messed things up here. Let me write that again. So 54 is right over here. Okay, so the distance from here to the mean is 6 spaces away. From 60 to 54 is 6 spaces away, right? So we do 60 minus 54, which is 6, and we take the absolute value of 6, which is still 6, right? Now, what if I wanted to know how far 10 is from the mean? How far is it from here all the way to here? Well, we could do 10 minus 54, except that would give us negative 44. We don't want negative answers, so that's why we're just taking the absolute value. Okay, and the absolute value of negative 54 is just positive 54. The absolute value of negative 44 is positive 44. Okay, and that's telling us that the distance from 10 to the mean, which was 54, is 44 spaces. Okay, and we're doing that for all of these numbers here. How far is 90 from the mean? It's 36 spaces away. How far is 80 from the mean? It is 26 spaces away. How far is 30 from the mean? It is 24 spaces away, okay? Now, why are we doing all of this? Well, remember, our goal is to get some indication of how spread out the data is. Is it really spread out or is it not very spread out? And one way to do that is to find where the center of the data is, and then to ask ourselves, okay, well, if the center of the data is here, how far away are all of these other points from the center? If the other points are really far away from the center, that indicates that our data is very spread out. If all of the other points are not very far away, if they're pretty close to the center, that indicates that our data is not very spread out. It's pretty clumped together. So now we know how far away each point is from the center, and we have all of this information, but it's too much information. It's kind of like information overload, right? What we want is a way to kind of summarize all of this information into just one number. And that's where step 3 comes in. We're going to find the mean of these distances that we got in step 2. And I already did that right here. So we're just going to add, not the original points of data, we're going to add the numbers that we got in step 2 together, okay, and then divide by how many numbers there are, which is still going to be 5. Not in every single problem that you're going to get, but in this problem, it was 5 over here, it's still 5 over here, and we got an answer of 27.2. So what does that mean? That means, on average, the points in this data set are 27.2 spaces away from the mean. Some are a little bit more than that, some are less than that. So for example, 6 is, so 60 over here. Let's take a look at this point over here. 60, that's 6 spaces away from the mean. So that's less than 27 spaces from the mean. This point over here, 90, that is 36 spaces away from the mean. So that's more than 27 spaces away from the mean, from the center. Okay, so some of these data points are more than 27 spaces away from the center. Some of the data points are less than 27 spaces away from the center, but on average, we can say that the points are about 27 spaces away from the center. So that number is a number that we use to measure how spread out the data is. And we can do the same thing for class B here. Let's just do another example. Step 1, find the mean. Okay, so here's our data. We're going to add it all up and divide it by how many numbers there are, in this case 4. Step 2, so 87.25, that would be right about here. Okay? Step 2 is we're going to, let me make that a little bit taller. Step 2 is we're going to find how far away is this spot from the mean? How far away is this point from the mean? How far away is this one from the mean? How far away is this one from the mean? And that's what we're doing when we subtract all of those numbers. So we just take this mean here, and notice that every single one of these we're subtracting 87.25. Back here, for every single one, we were subtracting 54, which was the mean for this example for class A. Okay, and then we're taking the absolute value because we just want to get positive answers all the time. We don't want to give any of those answers in terms of negative numbers for the distances. Okay, so 89, for example, this point over here is only 1.75 spaces away from the mean. So if the mean was at 87.25 and this point is 89, it's only a distance of 1.75 spaces away from the mean. Okay, so we find the distance between all those points and the mean. And again, that's like information overload. So to summarize all of these distances, we take the average of them. So we add up all of these distances, and divide by how many there are, and that gives us this number over here, which tells us that on average, the points of data are about 7 spaces away, 7.25 spaces away from the center. So if these data points are only about 7 spaces away from the center on average, and if these data points are about 27 spaces away from the center on average, that's indicating to us that these data points, because this number is larger, these data points are more spread out than these data points over here. And of course, we can see that's true just by looking at it with our eyes. This data is not so spread out. This data is very spread out, okay? All right, so moving along, what's the next thing we're going to do? Okay, if the minimum or maximum number changes, remember minimum and maximum are the only numbers we need to calculate the range. So if one of those changes, then the range will be strongly affected. And the mean absolute deviation, MAD, will be slightly affected. So let's take a look at this data plot over here. The range is 40, that's easy to calculate. 70 minus 30 is 40. And the mean absolute deviation, I'm not going to go through the whole process of calculating that. That's obviously a little bit more involved, but I already did it. The mean absolute deviation is 10. So that means if we find the center of this data, if we find the mean of this data, then on average, the points of data are 10 spaces away from the mean, from the center. Okay, now what if we were to take this data plot and just move this point further to the right? That is the maximum value which we moved. Okay, the maximum value was 70, we moved that. Now the maximum value is 90. Changing the maximum value will affect the range, because range is just maximum minus minimum, right? So the range now is 90 minus 30, which is 60. So you can see that the range jumped up by quite a bit, from 40 to 60. That's a change of 20. All right, let's put that in perspective a little bit and do a little bit of a review of percents. So I know that it changed from 40 to 60, which is a change of 20. By what percent did it change? We would have to take that difference of 20 and divide by the original number, which was 40, and we would get 0.5, which is 50%. So the range jumped up by 50% when we moved the maximum from 70 to 90. Now, what about the mean absolute deviation? Actually, first let me say that I want you to notice that even though we did change the maximum, nothing else changed, okay? None of these numbers on the inside changed at all. It was only the maximum value that changed, but the range doesn't care about that. The range doesn't care about any of these numbers on the inside. So if the maximum changed by a lot, then the range will change by a lot. But I like to think that the mean absolute deviation is a little bit smarter. The mean absolute deviation does know what's going on in the middle also. Remember, when we calculate the mean absolute deviation, we do take into account all of those points in the middle as well. Okay, so the mean absolute deviation realizes, now, wait a minute, you just changed this one point over here, but most of this data plot is still the same. And you can see that the mean absolute deviation, it realized that there was a trick going on. Okay, really not much changed, so it didn't change that much. It went from 10 to 12.5. And again, to put that in perspective, let's calculate the percent of change. So the difference between 10 and 12.5 is 2.5. 2.5 divided by the original number of 10 is 0.25, which is 25%. So when we moved the maximum value in this example from 70 to 90, the range jumped up by 50% because it's not paying attention to anything going on the inside. It's just thinking, oh my goodness, the maximum changed. All I care about is the maximum and the minimum. So it jumped up by a lot. The mean absolute deviation, on the other hand, it's saying to itself, well, wait a minute, you didn't change most of this stuff. You just changed that maximum value. So you know what? I'm not going to jump by all that much. I'm just going to go up by 25%. It's not as affected by a change of the maximum and minimum. All right, so let's move on now. Something similar, though. If a number other than the minimum or maximum changes, the mean absolute deviation will still be slightly affected, but the range will not be affected at all. So take a look at this example over here. And again, I want you to compare this first histogram with this second one over here. Sometimes I'm calling it a histogram, sometimes I'm calling it a data plot. Okay, but compare this one to this one. What changed from here to here? Well, the maximum stayed exactly the same, and the minimum stayed exactly the same. And so we sort of fooled the range into thinking that everything is the same, because the range only cares about the maximum and the minimum. So if that didn't change, then the range won't change. The range here is still 40, 70 minus 30, just like it was back over here. Except the mean absolute deviation, because it's paying attention to everything going on the inside, right? Think of the calculation that we did earlier. It's taking every single piece of data into consideration. So it does notice that this point moved from here to here. It used to be at 60, now it's at 50. So you can see that the mean absolute deviation did change. It went from 10 to 9, okay, or to approximately 9 if you actually do the calculation. So if a number other than the minimum or maximum changes, then the mean absolute deviation will still be slightly affected, but the range will not be affected at all. Okay, and to finish up here, here's the last thing we'll talk about. And to talk about this, I'm going to go back up to the first example that we did with Class A and Class B. If one data set is very spread out and another is not, we can visually, just with our eyes, we can determine which data set has a higher range and mean absolute deviation even before making any calculations. So just by looking at this data here, try to forget what the answers were. If your memory is good enough to remember from before, my memory isn't. Maybe yours is, but try to forget it. If somebody just gave you these two histograms over here and just asked you to look at them, okay, just by looking at them, which histogram would you say is more spread out? And the one which is more spread out is going to have a higher range and a higher mean absolute deviation. The one which is not quite as spread out is going to have a lower range, lower mean absolute deviation. So this one over here, hopefully you realize, is more spread out than this one over here. And so even before you did any calculations, you would be able to predict that the range and the mean absolute deviation should be higher for this one. And I'll just remind you now of what the calculations were. The range was 80. The mean absolute deviation was 27.2. Okay, so both of those values were higher for this histogram than for this one over here. Here the range was only 20 and the mean absolute deviation was 7.25. Okay, so just by looking at the data, we can tell, as long as there's really a big difference in how spread out they are. If it was just a small difference, we might not be able to just see it. But if it's a really big difference, we'll be able to tell which data has a larger range and a larger mean absolute deviation. Okay, so I'm going to end the video there, and have a great day.